Hey everyone, and welcome back to edritt. In this lecture, we are gonna see the sequence of binary number. Basically, we are gonna see how a 3-bit binary number will have equivalent values in decimal. Similarly, how a 4-bit binary would have equivalent values in decimal. And those are something which is important to recall, but throughout the course curriculum, you will automatically call them, so you don't need to mug up that stuff. Just whenever required, you need to refer those. So let me try to show you the possible combinations in a 3-bit binary number. So I have 3-bit binary number. So in this 3-bit binary number, as n is equal to 3, how many possible combinations are there? Possible combinations are 2 to the power 3, which is equal to 8. Now, let me try to write down these combinations. So I'll say my MSB as B2, LSB as the NSB as B1 and the LSB as B0, and I'll try to write the decimal equivalent of the same. So what possible combinations I can have? 001, 000, and then 001, and then I can have 010, 011. You see, one at a time is toggling, right? Now, next up I have is 100, and then 101, 110, and then 111. Now, the equivalent of each is 0, 1, 2, 3, 4, 5, 6, and 7. Now, let's take the example of a 4-bit binary number. Okay. In case of a 4-bit binary number, the n is equal to 4, which means total 2 raised to power 4 combinations are present, which means total 16 combinations are there. Okay. So I'll represent my bits as B3, B2, B1, and B0, and the decimal equivalent. So it will be 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, double 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 101011, and then few more numbers I need, so I'll put them here. 1100, 1101, 1110, and then 1111. Okay, and the decimal equivalent. This is B3, B2, B1, and B0, and the decimal equivalent. So the decimal equivalent will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay. So the conclusion is, in this lecture we saw how a 3-bit binary number will have its equivalent decimal number, and how a 4-bit binary number will have its equivalent decimal number, and you can extend it to the further bits like 5, 6, 7, and up to n. What is to notice is the toggling which is happening, like the bit 0 will toggle 0, 1, 0, 1, 0, 1, 0, 1. Bit 1 toggles each two cycles, I can say, or after each two toggles of bit 0. So 0, 0, after that it will toggle, and then 1, 1, after that it will toggle back. Similarly, this toggles after every 4, and this toggles after every 8. So if you notice this pattern, right, can I say that this toggles after every 2 to the power 0 times, and this toggles after every 2 to the power 1 times, this toggles after every 2 to the power 2 times, this toggles every time after 2 to the power 3 times, right? So for nth bit to toggle, it requires 2 to the power n times. Okay, so after 2 to the power n times only, nth bit will toggle. after and 2 to the power n times only nth bit will toggle in a binary number system. So this is all for this lecture. Thank you for watching this video. I hope to see you in the next one. Bye bye.